Welcome to Module 3, focusing on what-if scenarios, specifically counterfactual models and the equity dimension. We'll be exploring growth scenarios and subgroup analysis as part of the Hare root cause theory training program. Our learning objectives for this module include explaining counterfactual models, comparing Albuquerque's actual trajectory with 4 growth scenarios, interpreting the inverse relationship between growth rate and timeline, and analyzing disaggregated data across 9 student subgroups. Counterfactual models are mathematical reconstructions of what data would show under different policy regimes. They ask, what if about the past, unlike projections which forecast the future. For example, if a specific growth rate had been achieved since 2011, the 2024 score would be different from the actual result. The central question driving this analysis is, what would Albuquerque's grade 4 reading trajectory have looked like if the district or state had mandated a minimum growth standard beginning in 2011? To build these models, we held the baseline constant at 201 for 2011 and used an observed standard deviation of 1.32. We applied 4 different growth rates per 2-year NAEP cycle. Remember, these results are reconstructions of the past, not future projections. The baseline parameters for all 4 counterfactual scenarios are a 2011 score of 201 and an observed standard deviation of 1.32, derived from 2009 to 2024 TUDA data. This table shows how each growth scenario translates into scale points per NAEP cycle. For example, a 0.25 sigma scenario, the national norm, equates to 0.33 points per cycle, while 2.0 sigma equals 2.64 points per cycle. We are modeling 4 growth scenarios: 0.25 sigma, representing the national norm of 1-year typical growth; 0.5 sigma, double the norm, requiring structured literacy; 1.0 sigma, 4 times the norm, representing high dosage intervention; and 2.0 sigma, 8 times the norm, indicative of transformative, evidence-based instruction. This table presents the full data for the counterfactual scenarios, showing the projected scores for each growth rate compared to the actual scores across the years up to 2024. In the 0.25 sigma scenario, the score increases from 201.00 to 202.98, gaining almost 2 points over 13 years. Although small, this trajectory is upward, contrasting with the actual trajectory where 8 points were lost. The direction of change is more important than the immediate magnitude. The 0.5 sigma scenario results in a gain of almost 4 points, moving from 201.00 to 204.96. This rate is double the national norm. While still far from proficiency, this rate would achieve proficiency in 56 years. With the 1.0 sigma scenario, nearly 8 points are gained. This gain matches the 8 points lost in the actual trajectory. At this rate, the system makes real progress, potentially reaching proficiency within 28 years, a single generation. The 2.0 sigma scenario shows a gain of nearly 16 points. At this transformative rate, proficiency could be achieved in just 14 years, within a single generation. This result suggests a significant, evidence-based instructional shift with accountability. Comparing the actual 2024 score of 201, which is 8 points down from 2011, shows a declining trajectory. In contrast, the counterfactual 0.25 sigma score of 202.98 is up by almost 2 points, illustrating a rising trajectory. Direction matters greatly in these models. The actual 2024 score is 201, compared to a counterfactual 2.0 sigma score of 216.84. The gap between these scenarios is 15.84 points, which represents the cost of inaction. Comparing the actual trajectory, which declines by 8 points, with all counterfactuals, we see the actual path moving away from proficiency, 238, while the modeled trajectories move toward it. The potential gains range from 2 points in the 0.25 sigma scenario to 16 points in the 2.0 sigma scenario. The key finding from this modeling is the inverse linear relationship between growth rate and time to proficiency. Every doubling of the growth rate halves the time required to reach the proficiency target. Their relationship is precise. This table demonstrates the inverse linear relationship. Doubling the growth rate from 0.25 sigma to 0.5 sigma halves the timeline from 112 years to 56 years. This pattern repeats, showing that doubling the growth consistently halves the timeline. Applying the Hare-Hale model, which links growth rate to the time required to reach proficiency, we can classify the timelines. The actual rate of -0.71 sigma means an effective 1,120 years to proficiency, classified as, quote, critical. Only the 2.0 sigma growth rate is transformative, achieving proficiency within 14 years. The entire range of possibility is between the status quo, an effective 1,120 years to proficiency, and the transformative standard of 2.0 sigma growth, which achieves proficiency in 14 years. The determining factor is the growth rate. We now transition from aggregate, all students' data, to a disaggregated analysis. Aggregate scores often mask deep inequities, and a true focus on equity requires examining data at the subgroup level. Disaggregation is crucial because aggregate scores hide inequities. Federal law requires subgroup reporting. Different populations have different growth trajectories, and equity demands this level of analysis. We will now examine the 9 subgroups in Albuquerque public schools, including all students: Hispanic, white, economically disadvantaged, not economically disadvantaged, English learners, students with disabilities, male and female students. Note that English learners is the only subgroup with positive growth. The Hispanic subgroup, the largest demographic, has a 2024 score of 193 and an effect size of -0.58 sigma. This negative growth means the gap widens every cycle. At the threshold, the timeline to proficiency is 1,000 years. The white subgroup has a 2024 score of 226, closest to proficiency. However, with a -0.52 sigma effect size, they are in active retreat. This extends their timeline to proficiency at the threshold to 220 years. The economically disadvantaged subgroup has a 2024 score of 189 and the largest G2P gap. With a -0.60 sigma effect size, this population is most in need of accelerated growth, facing a 269-year timeline at the threshold. Students who are not economically disadvantaged score 234 in 2024, only 4 points from proficiency. Yet their -0.53 sigma effect size means an effective 1,140-year timeline at the threshold. The English learners subgroup is the only one with positive growth, at +0.12 sigma. This means the Hare-Hale proxy does not apply. With this growth, proficiency could be reached in just 25 years at the 0.25 sigma rate, making them the key exception. Students with disabilities have the lowest 2024 score at 168, the furthest from proficiency. Their effect size of -0.54 sigma results in a 370-year timeline to proficiency at the threshold. Male students have a 2024 score of 199 and share the same -0.71 sigma effect size as all students. This equates to a 580-year timeline to proficiency at the threshold. Female students have a 2024 score of 202. Despite being slightly higher than males, their effect size is near zero at -0.05 sigma. This low growth rate, coupled with a large gap to proficiency, produces the longest timeline, 1,370 years. This table summarizes the 2024 scores, growth rates, and resulting timelines for all subgroups analyzed using the Hare-Hale model. Notice that only English learners show positive growth. This chart illustrates the current scale score gap for each subgroup relative to the proficiency target of 238. Students with disabilities have the largest gap at 70 points, while not economically disadvantaged students have the smallest gap at 4 points. Here is a heat map visualizing the years required for each subgroup to reach proficiency, assuming growth is at the 0.025 sigma threshold. The darker the red, the longer the timeline. Our first counterintuitive finding shows that economically disadvantaged students have a larger gap to proficiency, yet a shorter timeline compared to all students. This occurs because the larger standard deviation in the disadvantaged group results in larger scale point increments per cycle, shortening the required timeline despite the larger gap. The female paradox shows that female students score 3 points higher than males, yet face a timeline nearly 3 times longer, 1,370 years versus 580 years. Their near-zero growth rate cannot close their large gap to proficiency, resulting in the longest timeline. The key lesson from the comparison of female and male subgroups is that a slightly better score is meaningless without growth. The female subgroup's near-zero effect size produces the longest timeline of any subgroup. The not economically disadvantaged subgroup scoring just 4 points below proficiency, is in active decline with a negative 0.53 sigma effect size. This results in a projected 1,140-year timeline at the threshold, proving the problem is systemic. The negative growth we observe is not confined to the most vulnerable populations. It is systemic. Every subgroup except English learners has negative growth, indicating the entire system is in retreat. English learners are the crucial exception, with the only positive effect size at 0.12 sigma. Despite having the lowest score, their positive growth means they could reach proficiency in an estimated 25 years. Comparing English learners with positive 0.12 sigma growth and a 25-year timeline to all students with negative 0.71 sigma growth and a 1,120-year timeline, we see that the difference is the growth direction. The English learner data serves as a natural experiment. It shows that positive growth, even below the national norm, yields infinitely better outcomes than negative growth. This strongly supports the Hare-Hale theory that the root cause is the growth rate, not the initial gap. As a practice example, given a score of 195, a standard deviation of 2.0, and an effect size of negative 0.30 sigma, the calculated gap to proficiency is 21.5 sigma. Applying the Hare-Hale proxy, this results in an 860 school year timeline. We've covered several critical findings, including the drivers of subgroup differences, the implications of the English learner exception, and how the female paradox challenges traditional performance evaluation. Key takeaways include the systemic nature of negative growth across most subgroups, the fact that better scores do not guarantee better outcomes without positive growth, and the power of the English learner exception to transform timelines.